In this video, we'll be covering example 6 on page 214 of the grade 12 Maths Handbook and Study Guide. It reads, given the equation of a circle with center O is x squared minus 4x plus y squared plus 2y minus 20 equals 0, A, determine the coordinates of O and the radius of the circle. So the first thing we have to do is complete the square and write the equation of the circle in standard form. We're going to group the x's together. They've done that for us already. I'm just going to rewrite the equation because it's easier when we have the equation right on top of our work in. X squared minus 4x plus y squared plus 2y. And I'm going to take the constant over, so it's equal to 20. Now we're going to write it as x, or half the coefficient of x, is minus 2 all squared, plus y plus a half the coefficient of 2 is 1 all squared is equal to 20, and then plus 2 squared is plus 4, and plus 1 squared is plus 1. Don't forget to add each of these on the right-hand side squared, and it's always a plus sign because we are squaring it. So the equation of our circle is x minus 2 all squared plus y plus 1 all squared is equal to 25. And they asked us to determine the coordinates of O and the radius of the circle, not to get the equation of the circle. So don't forget to write down your answer. Circle center is at positive 2 and negative 1, and my radius is equal to the square root of 25, which is 5 units. Units because it's a length. Question B now says, if KP is the diameter of the circle and P is the point 5,3, determine the coordinates of K. So 5,3, that's an x and y coordinate on the circumference of the circle. And for a question like this, it's really useful to draw a diagram so you can actually have a visual representation of what the circle looks like and where K and P are on the circle. So there's my diameter. Remember, diameter always passes through the circle center. We worked out in A that the circle center is 2 and minus 1. And it tells us P is the point 5 and 3. So that'll be up here somewhere. And that's point P. And now we're looking for the coordinates of K, which is x and y. So now we're going to use a little bit of grade 10 geometry, where we know the circle is the midpoint of the line. So we're going to use midpoint formula, which tells us that if we take x1 plus x2 over 2, that gives us the x value of the midpoint, which in this case would be the x value of the circle center, and y1 plus y2 all over 2 is equal to the y value of the midpoint of the circle center. So we've got the x value of K that we're looking for. x2 is going to be the x value of P, which is 5, all over 2 equals to the circle center, or the x value of the circle center, which is 2. So we multiply both sides by 2, we get xk plus 5 is equal to 4, and we take the 5 over to the other side, and the x value of k is equal to minus 1. And we do the same thing with y. So we're going to have the y value of k plus the y value of p, which is 3, all over 2 is equal to the y value of the circle center, which is minus 1. And we're going to have y plus 3 is equal to minus 2. We just multiplied both sides by 2. And then we're going to have y equals minus 2 minus 3, which is minus 5. And answer the question, it asks for the coordinates of k. So k has coordinates minus 1 and minus 5. In our next video, we'll be looking at straight lines and tangents to circles and covering a few more complex examples in analytical geometry.